Okay, so in today's video, I'm going to continue building my version of the ultimate small garage workshop by adding a dedicated storage and organization system for random pieces of small hardware that is currently scattered all over my workshop. Okay, so all over my workshop, I have many random pieces of hardware. Things like this switch or this little crossbee clamp. These are things that don't really fit in with the normal type of project I would be working on here in my workshop, so I don't keep large quantities of items like this. I also don't use it very often. So when the day comes that I need the switch, I often can't remember that I actually have it or where I stored it, so I end up going out to the shop and buying it again, only to find out weeks or even months later when I pull open a random drawer that I had the switch all along. So here are just a few examples of the type of items I'm talking about. You know, like this thumb screw. It doesn't get used in every project I build, but the day I need it, it is very handy to have. So today I want to build a dedicated storage and organization system for random pieces of hardware, small items that I keep small quantities of. But a very important part of this design or the idea is that I need to be able to very quickly determine whether what I'm actually looking for is in the unit. Because these items don't get used very often, when I'm building a specific project or working on a specific project, I need to be able to very quickly determine whether I actually have the item I'm looking for or if I have to go out and buy it, if that makes sense. So the idea is to build a 3-component storage system that will firstly consist out of a housing, which will allow me to fix the unit to the wall. Inside this housing, I will facilitate 2 rotating wheels that will rotate about a horizontal axis, almost like a Ferris wheel. And on these wheels, I will have small compartments. The fact that these wheels can rotate will allow me to very quickly view all these storage compartments and see whether what I'm looking for is actually in the unit. Now guys, I'm going to have a bit of fun with this project and use a few methods and materials that I wouldn't generally use, but I want to think outside the box and explore a few other ideas. I will be making plans available for the project, so if you guys want to support the channel, the link will be down below in the description of this video. Okay, so I'm going to get started with the housing. Now the housing is not going to be anything super complicated. It's 2 side panels, a back panel and a top panel. Now the top panel isn't exactly necessary. The unit will still function kind of like a toilet roll holder with 2 sides and a backing to facilitate a horizontal bar which will accommodate the rotation or be the rotating axis. But I'm adding the top panel to act as a type of shelf so that I can still stack stuff on top of the unit, and it will also in a way kind of prevent dust from coming from the top and settling inside the storage containers or compartments, because I'm not going to add doors or make this an enclosed unit. It can be done, but I don't feel like doing that. Okay, so now this is the 4 main panels that will be assembled to make up the housing: the back panel, the top panel, and the 2 side panels. But before I can assemble it, there's one more piece of preparation I need to do. I need to drill holes to accommodate a horizontal pipe that will facilitate the rotation of the Ferris wheel component. Now I could just match the pipe with a hole because the wood will act as a type of a bushing. It's going to be a low speed, low load rotation, but I would like the operation to be as smooth as possible, so instead I'm going to use bearings. So for now, I'm not really going to cap or retain or place some kind of retainer to keep the bearing in its place, because I might want to disassemble the unit later for demonstration purposes and to maybe paint the housing. So for now, I'm just pushing them into their seatings and I will be installing the pipe into it. It will function for the demonstration, and when I'm finished, I will cap them so that they are well kept in place. Okay, so this is now pretty much the housing complete with the two rotating axes. Onto these axes, I'm going to install almost like a drum, which will obviously rotate because of the bearings. Into the drum, I'm going to install small compartments, almost like a Ferris wheel, and I'll be able to scan all of these small compartments with the items stored inside of it very quickly by just spinning the drum. Right, so this is going to be a wall-mounted unit, or a fixed wall-mounted unit. So I'm fixing the housing to the wall in the meantime to make the rest of the assembly a bit more comfortable or easier to do, because the bottom wheel is actually going to extend beyond the housing at the bottom. Now, this might seem a little bit low, but remember, I need to be able to very quickly and comfortably see what's inside the containers when I am spinning the wheels. Okay, so now the project is finally ready for the third and final stage or component, which is the storage compartment. Now, originally it was my intention to create a long rectangular type box with little subdividers to create the storage compartments, then offset the horizontal axis so that the box is always hanging down towards the ground when the large wheel is being rotated or turned, so that the items stored inside the compartments don't accidentally drop out. Since then, I decided to instead use a piece of 80mm PVC downpipe, cut it in half along its length, cap it and install dividers. The rounded surface of the PVC pipe is going to work better with the design. Exactly why, I will demonstrate when I start assembling the rest of this project. To neatly cut the PVC pipe down along its length became the next obstacle. If I had a bandsaw, it would have made my life a lot easier, but I don't, so I made this jig so I can use my circular saw. Okay, so at this point it was my intention to cut wheels out of some material, probably MDF, using a hole saw and then gluing or screwing them in through the PVC at the end caps and as dividers. But I then decided it will be quicker and cheaper and easier just to print these. Right, so this is now the PVC pipe or half PVC pipe with the 3D printed end cap installed or glued on using PVC weld or PVC cement. As you can see, there's a hole which is offset from the center, and I'm going to install a pin through this hole into the bearing on the wheel, which will allow this to always hang well down when the large wheel is being rotated. Okay, so to allow the tray to rotate or stay horizontal when the large wheel is being rotated, I'm going to use normal shank type cap screws. I'm going to cut the top off with my grinder and then use 2 nuts to attach the threaded area to the printed end caps on the trays. Then, because I match them in size, I will seat the shank inside the bearing and this will facilitate the rotation. Okay, so this is now the 2 rotating wheels with 4 storage trays each. The final addition is the partitions. Okay, just quickly before I get to the partitions, the reason I went for a rounded shape instead of a box shape on the trays is because I can make the design more compact. If I went for a box shape over here, I would need to increase the radius of this wheel because the corners will likely get caught on that center post over there. Now, if I ever want to improve on this design or the functionality of this concept, I can always add a type of a braking system or something that would, in a way, restrict the rotation of the wheel in a way that will prevent it from, running away or freewheeling, which can cause the items to fall out of the trays. But at this stage, if I turn it at a reasonable pace, it will function exactly as I had intended. Okay, so that's all the partitions now installed. Now I'm not going to glue the partitions in place like I did with the end caps because I like the fact that I can slide them up and down to change the size of the storage compartment. And I can also add more, decreasing the size of the storage compartments but increasing the storage variety of the entire unit. So with my project, I think I have achieved exactly what I was trying to achieve. I have a small parts storage and organization system that I can very quickly scan through to see whether what I'm looking for is actually stored in the unit. Now, some people might argue that I could have bought plastic storage organizers and I would have gotten a similar effect, but I don't really think so. And that's not really what this channel is about. It's about thinking outside the box, designing from scratch and building what I design. And the goal is it needs to be functional, and I think this is exactly what I achieved today. And that is pretty much it for today. I hope you guys enjoyed it. Remember, if you have anything you would like to add, please drop it in the comment section down below. I really enjoy hearing from you guys. And if you aren't subscribed yet, you should do that now so you don't miss out on future projects like this. Now guys, for the people that want to support the channel, I will be posting plans to my plans website and linking it down below. Keep in mind that there is a lot of 3D printed parts. So if you don't have that facility, you will probably have to manufacture that in some other way, like out of MDF. And if you have that facility, I will add the STLs to the plans post on my website and you can download it over there. I will also add all the hardware I used, like the bearings, to my Amazon storefront and link that down below as well. But keep in mind, for the plans and for the hardware, I work in metric, so I matched metric bolts with metric bearings. If you work in imperial, you'll probably have to do that conversion as well. But for now, that's pretty much it. Thank you so much for watching. I hope you guys enjoyed it. Till next time. Cheers.